Okay, I'm going to give you some help on your dimensional analysis. Remember that we need to be doing DOK levels. So these have a couple of twists in them, which bumps up that DOK level to 2, maybe 3. So first we need to figure out from the first question, you either have a 1 or a 5, depending on what form you have. It says the moon orbits at 240,000 miles from Earth. Well, we can stop there because they've given us a distance, so we're going to put what we know over 1. So we have 240,000 over 1. Now, here's where you're going to lose points if you don't put that unit. Units are very important in science, and these might seem simple problems now, but when we start getting into AUs and miles and kilometers and light years and parsecs, that sort of thing, it's going to be important that we can see where those units fell out. So then the twist here is that how many seconds would it take the radio waves to reach Earth? Well, we know we want our answers to be in seconds. The twist is that you need to remember or apply what you know, that radio waves are a form of light. If you remember, radio waves have the longest wavelength and have the less amount of energy, and that gamma rays are the shortest wavelength and have the most energy. Remember, we talked about Marvin the Martian. You can shoot Wile E. Coyote and poof, he's gone because it has so much energy. So we need to look at our conversion factors and see if we have something that has miles and seconds. And voila, we do. In a vacuum, the speed of light is 186,282 miles per second. So now we just have a direct conversion. Miles cancels out. We're left with seconds. I'm a visual learner and I like to check my work. So I'm going to take everything on the top, 240,000 seconds over 186,282. And we divide those and we end up with 1.29 seconds. Okay? How long would it take the beast to get there? Well, there's a twist in here because you might not know where to start. And the thing that we've been given is the distance to the moon. So again, you're going to start with 240,000 over 1 miles, don't forget those units, times, well, what do we want to get our answer in? Does it say seconds? Does it say hours? Which one do we want? Well, we look up at our conversion factors and we're going to try to find something where we can go from miles to hours or get rid of miles and end up with a time frame. So we're going to use how fast the beast can go. So the beast can go 102.5 miles per hour. Anytime you're given a rate, remember you can write that any of two ways. You can write it this way, or you can write it as I can go 102.5 miles in 1 hour. Both of those equals 1 and are both can be used in conversion factors. It all depends on what unit you're trying to get rid of. Okay, so now the miles goes away and we're going to have 240,000 over 1 times 1 hour times 102.5. And the answer we end up with is 2,341.5 hours. Okay, question number 3. How many centimeters away is the sun from Mars? Well, again, this is one of those twists. You got to figure out what you've been given, and so the question really doesn't tell you that. You need to remember that you have the distance to Mars from the sun. You either look at your pocket solar system or the tables we did or the scales that you just got done for your projects. So from those things, you should know that it's 1.52 AUs from the sun to Mars. Now I'd ask for centimeters. There's nothing in our conversion factors that goes straight to centimeters, but there is kilometers, and there's kilometers can be changed to miles, and miles can be changed to AUs. So in our conversions, we're going to go from AUs to miles, then we're going to go from miles to kilometers, and then kilometers to centimeters. Okay? So So we have our 1.52 AUs. We want to get rid of AUs. We want to end up with miles. So the conversion factor we have is 1 AU equals 92,955,807.2 miles. There's that unit again. So the AUs drop out. I'm going to continue the problem down here because I ran out of space. So we have miles and we want to change it to kilometers. So then we have in 1 mile there's 1.6 kilometers. So then our miles drop out. And then we want to go to centimeters. In 1 kilometer, how many centimeters do we have? I'll change colors so we can see what's going on. Oh, it didn't change colors. Let's try again. Nope, okay. We'll work on that later. Okay, so this is where we're going to go to kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters. This makes it a DOK too because it didn't come out and tell you that you have 1 kilometer. How many centimeters do you have? It expected you to analyze, use, conclude, apply the things you knew from level 1, which is this. So we have 1 kilometer and we're going to change to centimeters. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 100,000 centimeters in 1 kilometer. So then kilometers goes away. Let's see, do I have an eraser? Eraser. Oh, it doesn't look like it. So let's see. Everything on the bottom is 1, so I don't have to rewrite that. So I have 1.52 times, I know this is messy, 92,955,807 okay. I'm going to just go on to the next. Okay, so we know that we have 1.52 times 92,955,807.2 times 1.6 times 100,000 centimeters. So if we do all that nice and groovy math, we get 2.26 times 10 to the 13th. Okay, problem 4. Again, there's a twist. How long would it take the beast to get there in light years? Well, you have to think about what you've been given. The question is light years, and you don't have a distance. But we do know that it's 1.52 AUs from the sun to Mars. We know that we can get rid of AUs like we did in the previous problem by taking it times 92,955,807.2 miles. The unit of AUs cancels out. Now we want to get rid of that miles. We're going to use the rate that has miles and hours. So we're going to use the speed of the beast. So in 1 hour, the beast can go 102.5 miles. Miles goes away. So we ask the question, are we where we need to be? It says how long, and again, it didn't ask for seconds. And we have a unit that means time, so we can stop here. So again, everything on the top. Divided by everything on the bottom. And then that gives us the wonderful, beautiful number, 137,866.6. Voila, done, got all the points. No, wait, Dr. J, you forgot something. Oh yeah, those units, darn it. Okay, you have to show all this dimensional analysis. That's the whole point. That's the concept of why we're doing these problems. This answer, yeah, we got it. It's cool. But it's all this stuff that's important. Okay, see you soon. Bye-bye.